Hi everyone. In today's lesson we're going to start the second part of Unit 3.2, and in our first set of notes we're going to review what we've learned in Algebra 1 about the coordinate plane. So if you take a few minutes and just label the graph with things that you remember from Algebra 1, some things that you might recall are that the horizontal axis is referred to as the x-axis, and the vertical axis is referred to as the y-axis. Where those two axes meet in the center is called the origin. And it has the coordinates 0, 0. Okay, when we graph, we say that we plot the points in each of 4 quadrants. The x and the y-axes divide the graph into 4 quarters. In the upper right-hand quarter, this is quadrant 1. If you go to the left, upper left-hand quadrant is quadrant 2. The lower left is quadrant 3. And lower right is quadrant 4. So if we plot a point in the first quadrant, we're going to the right on the x-axis, and then we're moving in the positive direction on the y-axis. So if we're plotting a point where both x and y are positive, it would end up in the first quadrant. So you go to the right and then up. In the second quadrant, we're moving to the left on the x-axis, but then we're moving in the positive direction on the y-axis. So x would have a negative value, but y would be positive. In the third quadrant, x and y are both negative. You're moving in the negative direction on the x-axis, negative direction on the y-axis. And finally, in the fourth quadrant, you're moving in the positive direction on the x-axis, but negative direction for y, so it's positive, then negative. Okay, if we plot the points 4, 0, 2, 3, negative 4, 5, and 0, negative 4, you get a little bit of practice. Okay, so the point A at 4, 0. So 4 is positive for x, so start at your origin and count to the right 4. 1, 2, 3, 4. And then it says 0 for y, so we're going to stay right here on the positive x-axis. So the point A at 4, 0 would be right there. For the point B at 2, 3, I'm going to change colors here. Again, you start your counting at the origin always. So we want to go 2 to the right for x because it's positive 2. So 1, 2, then up 3. So there's point B. Again, at positive 2, positive 3. Notice how it's in the first quadrant because both x and y are positive. For our next point, we have C at negative 4, 5. Again, start at the origin. Count 4 to the left. 1, 2, 3, 4. And then positive 5. 1, 2, 3, 4, 5. So point C is going to be way up here. Negative 4, positive 5. And then finally, the point D is at 0, negative 4. That means we're not going to the left or right at all for x, and we just want to go negative 4. 1, 2, 3, 4. So the point D is down here. 0, negative 4. Okay, next we're going to take a look at how to find distance between pairs of points using a graph. So it says use the graph below and find the distance between each of the following pairs of points. If we want to find the distance between points A and B, first I'm going to take and draw a line segment. You should use a ruler on your notes and just connect points A and B. Now if you notice, this is a horizontal line segment. It's really easy to find the distance between those 2 points. All you have to do is count the squares. Those 2 points are 4 squares apart, so you can say the distance between those 2 points is 4. Okay, just as easy as finding the distance between a vertical pair of points, and that's what we've got in the second case. If we want to find the distance between C and D, draw on that line segment, and then count the number of squares in between. 1, 2, 3, 4, 5, 6, 7. So the distance between C and D is 7 units. Now remember, when we talk about distance in geometry, we would say AB with no symbol for a line segment above it equals 4. That means the length of line segment AB is 4. The length of line segment CD equals 7. Okay, in the next case, the distance between points E and F, well, notice that this is not horizontal and it's not vertical. Okay, what we can do in this case is turn this into a right triangle. So if we drop down this vertical segment, and then we draw in a horizontal segment, notice that we've created a little right triangle. Okay, so now we can use the Pythagorean theorem because we can count to find the lengths of these two sides, 3 and 4. And let's just call this distance the hypotenuse, x. So according to the Pythagorean theorem, we would do 3 squared plus 4 squared is equal to x squared. 3 squared is 9. 4 squared is 16, and when you add them together, we get 25. Okay, 25 equals x squared, so take the square root of both sides, and we get x equals 5. So the length, or the distance between points E and F, is equal to 5. Now, if you end up with a radical that is not a perfect square, you do need to simplify as much as possible. Okay, in our last case, we're finding the distance between points G and H. So first connect those two. And now we're going to turn this into a right triangle by drawing in the horizontal line segment and a vertical line segment. Any horizontal line is perpendicular to a vertical line. The length of this side of the triangle is 3. The length of this side of the triangle this time around is 5. And so I'm going to call this distance y over here. So in the Pythagorean theorem, we'll do 3 squared plus 5 squared this time is equal to y squared. 3 squared is 9, 5 squared is 25, that's equal to y squared. 25 and 9 adds up to 34. Okay, we've got to take the square root of both sides. So when we do that, we are going to end up with y alone. Now, the square root of 34 can't be simplified. There isn't a perfect square that divides into it, so we're going to leave it first as a radical, and then we're going to take and actually go to the calculator and approximate it. So wavy equals sign means we're rounding or we're approximating. So do the square root of 34 on your calculator, and it works out to be about 5.83. Okay, that's it for the notes. Good luck on homework number 1.